Hi, in this video, I will be showing you problem number 7 of chapter 11, section 7. Test the series for convergence or divergence. Sigma, n varying from 5 through infinity, 1 over n times square root of ln of 5n. So anytime you see ln and n appearing in either the numerator or the denominator only, then the integral test would be a best option for these problems. So we are going to apply integral test. So we'll consider the relating function fx, which is equal to 1 over x times square root of ln of 5x. So what is integral test? Suppose f is continuous, positive, decreasing on the interval 1 through infinity, and let f a of n, a sub n, be equal to f of n, then the series sigma a n is convergent if and only if integral 1 through infinity, the improper integral 1 through infinity fx dx, is convergent. So if this improper integral is convergent, the series would be convergent. If the improper integral is divergent, the series would be divergent. So we have to first state that f of x is continuous, positive, and we have to prove that it is decreasing. The continuous and positive part does easily follow from the definition of the function. So as the function starts only at 5, so the function is okay. It's actually continuous and positive on the interval 5 through infinity. So f of x is continuous and positive on the interval 5 through infinity. Then we also notice that it is decreasing, which part we can, sometimes it's obvious, sometimes we have to use increasing decreasing test and find out the derivative and show that the derivative of the function is smaller than 0 on an interval. But here we don't have to go for that one because it's obviously decreasing. We can also prove it by taking the actual a, and we can actually show a n plus 1 is less than or equal to a n for all n. Is it true? So what is a n plus 1? Which is 1 over n plus 1 times square root of ln of 5 times n plus 1. Then a n is 1 over n square root of ln of 5 times n. We can definitely say n plus 1 is n plus 1 times ln of 5 times n plus 1 is more than n times square root of ln of 5n. So when we take the reciprocal, 1 over n plus 1 square root of ln of 5 times n plus 1 is smaller than 1 over n times square root of ln of 5n, which clearly shows a n plus 1 is smaller than a n for every n more than or equal to 5. So we can say the sequence a n, or in this case the function f of x, is decreasing on the interval 5 through infinity. We take 5 through infinity here because the series starts only at 5. So we have all the required. Now we'll find out the improper integral, evaluate the improper integral 5 through infinity f of x dx, which is integral 5 through infinity 1 over x times square root of ln of 5x dx. This integral can be evaluated by u sub method. So let's assume u equal to ln of 5 of x. Du will be equal to 1 over 5x times 5 dx. Outer derivative times inner derivative. This is chain rule. So these two, 5 and 5, get cancelled out. So it's 1 over x dx. So the integral, which is now integral 1 over x times square root of ln of 5x dx, can be written as integral 1 over square root of u, then this 1 over x dx, 1 over x dx can be replaced by du. So without the limits, now I can write this as integral u to the negative 1/2 du. So on integration it would become u to the positive 1/2 over 1/2. So it will be 2. I'm going to now replace this u with ln of 5x. It is square root of ln of 5x. So the integral that we have here, 5 through infinity fx dx, can be written as limit as t approaching infinity, integral 5 through t, all this 1 over x square root of ln of 5x dx, which we already evaluated, which is limit as t approaching infinity of the integral value which we evaluated turned out to be 2 times ln of 5x with the radical sign between the limits 5 and t. So it will be 2 times limit as t approaching infinity to square root of ln of 5t minus 2 square root of ln of 5 times 5, that the lower limit, which is ln of 25. As t approaching infinity, the whole thing is dominated by the first term because t approaches infinity and this involves t. The second one is after all a constant, so it is going to be just 2 times infinity or infinity. This shows that the improper integral 5 through infinity fx dx is divergent. As per integral test, whatever the behavior of the integral is the same as the behavior of the series. Therefore, the given series is also divergent. Therefore, by integral test, the given series sigma 1 over n times square root of ln of 5n, n varying from 2 through infinity, is divergent. Hope this video helps.